Our next topic is aromaticity. What is aromaticity? Aromaticity, this word has been derived from the word aroma. Aroma means the substance from which comes the fragrance. As you use the deodorant or some other substance which is emitting any kind of fragrance is called aromatic substance. So it was older concept that the substances which are giving an aroma are called aromatic compound. But as per scientific or technical definition, the aromatic compounds are those compounds which obey the Huckel rule, that is 4n plus 2 pi rule. So let me start. The benzene, the simplest aromatic hydrocarbon, occupies a key position in the study of chemistry of aromatic compounds. In fact, aromatic hydrocarbons containing benzene rings or condensed system of benzene rings are referred to as benzenoid hydrocarbons due to their structural similarity and aromatic properties. There is yet another series of compounds which exhibit aromatic properties but lack benzene-like structure and are called non-benzenide aromatic compounds. The compounds which are neither possesses benzenide structure nor they show any aromatic properties are called as anti-aromatic. So there are aromatic compounds, non-aromatic, anti-aromatic compounds, non-aromatic, anti-aromatic and aromatic compounds. So these are different kind of compounds. So the aromatic character, what is the aromatic character? So aromatic character, the benzene, a representative of the class for example, possesses the following unique aromatic character. So if we will study the benzene, that is this compound C6H6, it is very common organic compound. It is the base of the almost all the organic compounds. So it has following particular properties: that it is comparatively resistant to undergo addition reaction, that is its molecular formula suggests a high degree of unsaturation, but it does not respond to the addition reaction with HBr and halogens, that is HBr halogens, that is X2, that is chlorine, bromine, fluorine or iodine. So decolorization of bromine water and Bayer test with this which readily add to alkene double bond. However, benzene does not add additively with the chlorine but only under condition necessary for free radical addition, and catalytic hydrogenation also occurs only at a high temperature and pressure. So the compounds of this family like benzene and other alkenes like this type of compounds, what is the difference there? That I am telling you that these compounds readily undergo the reaction with HBr or halogens or bromine water test. They undergo bromine water test or Bayer's test, or they readily undergo free radical addition with the chlorine, or they undergo catalytic hydrogenation easily. So these compounds undergo due to unsaturation. Unsaturation means there is the scope of addition of other substrate, whereas benzene is also having a alkene structure, that is there are three these double bonds, and these are this basically benzene is an alkene, but it does not undergo these reactions as shown by these and other compounds of alkenes like this ethylene or some other compounds. So benzene is quite different. So first factor I told you, it was this comparatively resistant, they are comparatively resistant to undergo addition reactions, rings of benzene. Next point is high resonance energy. So high resonance energy, what is the resonance? Resonance is the phenomena when one compound is represented by more than one structure and actual structure is not certain. So its heat of hydrogenization is 212 kilojoule per mole and is rather low as compared with the calculated for the cyclohexatriene. So cyclohexatriene something different. This difference between the heat of hydrogenization of benzene is 212 kilojoule per mole, whereas the heat of hydrogenation of 135 hexatriene is 363 kilojoule per mole. So this difference between the calculated and observed value of heat of hydrogen is called resonance energy that provides a considerable stability to the benzene. Third point, its heat of combustion is very large as compared to that calculated for cyclohexatriene. Hence there is considerable stability of benzene. This is another way of calculating the resonance energy. Fourth point is it is a flat compound containing conjugated system of double bonds with planar geometry that alone permits a full pi overlap. So there are other points like it undergo mainly electrophilic substitution reaction like nitration, sulfonation, halogenation and Friedel-Crafts reaction, and it rarely undergo nucleophilic substitution reaction, but these reactions are not given by corresponding open chain polyene. So there is a difference between the benzene and open chain polyenes. The reaction shown by the benzene are not shown by the open chain polyenes, whereas the reaction shown by the open chain polyenes are not shown by the benzene. So the compound containing one or more benzene also possesses these features. All these benzene-like compounds are called benzenide aromatic compound, and property which imparts special stability unique to these compounds is referred to as aromatic character or aromaticity. So it will be seen in due course that presence of benzene ring is not essential condition for compound to show aromatic character. In fact, there are several compounds which have little resemblance to the benzene and yet they show typical aromatic character. Such aromatic compounds are called non-benzenide aromatic compounds to distinguish them from the benzenoids. So benzenoids are the benzene-like compounds. So next is the Huckel theory of aromaticity. So to explain these property, we invoke the Huckel theory of aromaticity, which show the various features. So what does Huckel theory of aromaticity says? So Huckel theory of aromaticity says, first point is, if the number of pi electron in a cyclic system is equal to 4n plus 2 pi, number of pi electron should be equal to 4n plus 2, that is 4n plus 2 pi electron should be there, where n is equal to 0, 1, 2, 3, etc. The compound is said to be aromatic. So if we put the value of n is 0, then 4n plus 2 is equal to 0 plus 2 is equal to 2. If we put the value of n is equal to 1, it is the 2, 4 plus 2. If we put the value of its n value 2, it is 4 into 2, 8 plus 2 is equal to 10. So this number of pi electrons should be there in a compound. So how many pi electrons are there in benzene? There are 3 pi bonds and each pi bond contains 2 electrons. So total 3 pi bonds will lead to 6 electrons. So the benzene ring is containing the 6 pi electron. The next point is, this rule is applied to ring carbon containing planar cyclic system in which each carbon is capable of being sp2 hybridized to ensure maximum overlapping of p orbitals for extended pi bonding. It has been extended to unsaturated heterocyclic and fused ring also. So second point, compound must be planar and it must have sp2 hybrid carbon. So let me show you again that this benzene ring, all the carbons are sp2 hybridized and this ring is planar, so it fulfills the second condition of aromaticity also. So third condition is, an aromatic compound must contain cyclic clouds of delocalized pi above and below the plane of the molecule. So third point is, an aromatic compound must contain cyclic cloud of delocalized pi electrons above and below the plane of the molecule. So pi electrons must be above and below the plane of ring. So fourth point is all atoms participating in pi bond must lie in the same plane. So this is almost similar to the second point, that compound must be planar. So all atoms containing pi bonds must lie in the same plane. So pi bonds must lie in the same plane. The system can also be an ion or ion, that is cation or anion. Fifth point is the number of pi electrons that fulfill Huckel's rule are 2, 6, 10, 14, 18. That is the number of pi electrons that fulfill the Huckel's rule are 2, 6, 8. If you will put the value of here n is 3, then it will be 4 into 3, that is 12, plus 2, that is 14 pi electrons. So they may contain 2, 6, 8, 10, 14 and 18 electrons. Sixth point is cyclic compound with 4 and pi electrons should be even less stable than their open chain analogues, and such cyclic compound are called anti-aromatic compound. So for an anti-aromatic compound there should be 4 and pi electrons. 4n means value of n can vary from 0 to 0, 1, 2, 3. If it's 2, then it's 8 pi electrons, and the compound containing 8 pi electrons will be called as anti-aromatic. So the examples of aromatic compound under Huckel's theory are, first is the benzene. So let's get on the from the here that first of all there should be 4n plus 2 pi electron should be in there. 4 and 2 plus pi means value of n can start from 0 to 1, 2, 3, 4, 5. So if we put the value of n is 1, then it's 6 pi electron. So are there 6 pi electrons, or we put the value of n is 0, so there are 2 pi, there should be 2 pi electron, or if we put the value of n is 2, then there should be 10 pi electron. So if we start from this, then we can see that are there 2 pi electrons? No, there are 2, 4 and 6 pi electron. So there are, when we put the value of n is 1, then there are 6 pi electrons. So it fulfill the first condition. Second condition, compound must be planar and there are sp2 hybrid carbons. So this compound is basically benzene ring is a planar compound and it has sp2 hybrid carbons. Third point is pi electron must be above and below the plane of the ring. So pi electrons are present above and below the plane of ring. Fourth is pi bond must lie in the same plane. So you may be asked the MCQ from here, where out of these 4 conditions, 3 conditions are given and one wrong conditions are when one wrong condition is given and you have been asked to identify the wrong statement. So you may read all the statement and may identify the wrong statement. Or you may have been given the examples of like benzene ring and other compounds to identify which of them is aromatic or non-aromatic or anti-aromatic. Suppose this is the compound, this is called naphthalene. So there are 1, 2, 3, 4, 5 double bonds. 5 double bond means there are 10 pi electrons. So there are 10 pi electrons, and how you will identify these 10 pi electrons? These 10 pi electrons are identified with by the putting the value of n is 2. So when the value of n is 2, there are 10 pi electrons and the compound is, this compound is aromatic. Suppose there is anthracene. The anthracene has 3 benzene rings. Further, this naphthalene also follows under other conditions, like all the carbon are sp2 hybrid, compound is planar, and other conditions. So this is anthracene, and let's check whether this compound is a aromatic or non-aromatic. So if you will put the value of 4n plus 2 pi here, if you put the value of n is 3, then it comes out to be there are 4 into 3 12 plus 2 14 pi electrons. So let's count, are there 14 pi electrons are present in this compound? So 2, 4, 6, 8, 10, 12 and 14. So first condition is fulfilled, that there are 14 pi electrons. 4n plus 2 pi electrons are present there when the value of n is 3. The second condition, compound must be planar. So this compound is a planar compound and all the carbons are sp2 hybrid carbon, and pi electron must be above and below the plane of the ring, and pi bond must lie in the same plane. So these conditions are general conditions. They may be given you, they may be given to you, or you may know them, but this condition you have to calculate this condition on the paper. So how to put this formula, Huckel's rule of aromaticity? If you will appear in some entrance exam or somewhere else, most probably the question comes from here, that compounds are given and you have been asked whether these compounds follow Huckel's rule or of aromaticity or not, or whether these compounds are aromatic or not. So you have to put the formula 4n plus 2 pi. So if you will be able to put this formula or interpret this formula or apply this formula on the given compound, you will solve the query or question very easily. So there are many other compounds or ions. It's not necessary that a neutral compound is a aromatic compound or compound which is following the Huckel's rule of aromaticity. If you have some compound with the charge given like this positive charge, then you may again write the Huckel's rule of aromaticity for it. For example, here only 2 pi electrons are present in this cation. There positive charge on carbon and there is a pi bond. So this pi bond pertains to 2 electrons, and this positive charge, this is here on this carbon, and this leads to sp2 hybridization. Okay, so this compound is following all the rules of Huckel's rule, and first rule, that is 2 pi electrons are present there. Further, the carbon is sp2 hybrid, so you will easily identify the ion, that whether it's aromatic or not, non-aromatic, or whether it's following Huckel's rule or not following Huckel's rule. For example, if you have been given this anion, and you have been asked about aromaticity of or Huckel's rule of aromaticity about this. So there are let's count, there are total 2 plus 2 plus 2, there are 6 pi electrons. So it is following Huckel's rule. When you have put the value, you have been put the value of n is equal to 1. So there are 6 pi electrons plus all the carbons are sp2 hybrid, and the compound is ring is planar, so cyclic planar ring. And always remember that the system should be cyclic. That is, Huckel's rule is followed by only cyclic system or cyclic compound like this. It has been not followed by this kind of compound. If you have been given this type of compound and there are 6 pi electrons, but this compound doesn't follow Huckel's rule because it violates this condition, that is, compound is not cyclic. So compound should be cyclic planar and cyclic planar sp2 hybridized, and further following this mathematical equation, that is 4n plus 2 pi. So if you will solve examples from the book, then you will learn it how to apply the Huckel's rule. So this was our topic for the day, that is Huckel's rule of aromaticity.